The art and science of navigation is understanding exactly where you are, exactly where you want to go, and how you're going to get there. And part of getting there is ensuring that you're on track or that you're on course. So to do this, you need to take a fix. Now, a fix involves certainty. So with offshore navigation, your only means of taking a fix through electronic means, which is the global navigation satellite system. And if you don't have electronic means, you have to deal with a bit of uncertainty and use an estimated position derived from your navigational records, which we'll cover in another subject. In coastal navigation, it's a different matter because we can rely on the visual fix, or a hybrid of visual and electronic fix. The range of options we have, we can take a bearing on something that we know a position of, such as a lighthouse or a buoy, or we can use a transit where we have two objects that we can line up together. We've got our depth sounder, which nowadays of course is electronic, and we can tell where we are on a, if we're on say a 10 meter or 20 meter contour, and combine that with other information. And we've also got radar, which we can use to find the range from fixed objects, such as coastline or building or headlands. So we've a lot going on for us there with a combination of visual and electronic means. So there is a hierarchy, with the most reliable position being beside a charted and fixed object such as a lighthouse. And then we can go through global navigation satellite system to a range of visual fixes or a hybrid of visual and electronic fixes. The most reliable method of determining a fix is just to rock up alongside something and be close enough to something fixed, such as Fastnet Lighthouse. You can also use proximity to a floating object, but it's not as good. The next option is probably the global navigation satellite system using GPS, Galileo or GLONASS, or some of the other systems, regional systems coming on. Now, they're not completely infallible, and they have been known to have mistakes. I myself experienced it about 10 years ago, that the position jumped about half a mile for 15 minutes, and it was only through visual means that I knew that it was in the GPS was giving me the wrong position. So GPS must be verified, particularly when you're in close coastal waters, and you do this through visual means or other electronic means such as radar or depth sounder. Next on the list is two transits. Two transits are a really super reliable way of determining your position, but the options are pretty limited. There aren't that many intersecting transits around where you need them, but when they are there, they're very reliable. The best type of transit is one where we're looking at two charted fixed objects, not buoys, because they can move around. So in the foreground we have a stone beacon. It's been there for 180 years, so it's unlikely to have moved, and that's known as the Black Man. And in the background, about 4 miles further back, and it's bang on the transit, just coming into transit there now, is a forest, and that's clearly marked on the chart. That's the forest at Raven Point, and the edge of it is quite distinctive on the chart, so I can very accurately predict where I am with that one. This is a transit on two buoys, and as you can see from the current there on the falling tide, there's about a 2.5 knot current, and that will move the buoys. So if I came back in 10 hours time, we would see the buoys have shifted. So transits on buoys aren't totally reliable, and you can see even as I talk, the buoys are moving around with the swirl of the tide. There's more tide under the red buoy than there is under the green buoy. So when you're approaching a transit, if the object in the foreground is to your right, then you need to move to the right. And if the object in the foreground is to the left, you need to move to your left. So after two transits, probably the best one would be a 3-bearing fix. I like doing the 3-bearing fix. Have a look at this piece I made earlier. So one of the great ways of finding your position when you're navigating along the coast and in sight of the coast and in features that are charted is using the 3-bearing fix, and it's a good alternative or a backup to the GPS. For the 3-bearing fix, you need a chart and some charted features, and you need the pencil and paper, and of course the hand-bearing compass. So the first thing you do is you just have a look around to see what's likely to be charted, and just over this shoulder here I've got a church, and that's on the chart. That's Rose Street Church, and further south is its twin church, and that's Bright Street Church. I'm going to use it. Churches are great because they reach a fine point. You know exactly where it is on the chart. It's the centre of the cross on the chart. And as I come around out to sea here, now it's a little bit hard to see, you see there's a fishing boat there, and just this side of the fishing boat there's a green pillar known as the Black Man, and that is also charted. So I'm going to use my hand bearing compass to identify, to get a bearing on those three. So I checked the chart to see if the three positions that I saw when looking around me are on the chart. And they are. And churches are always very reliable, as would a beacon. So we have the northern of the two churches, which is Rose Street, the southern of the two churches, which is Bright Street, and Black Man, which is the flashing green 5 seconds beacon. The thing to do is have them written down in your notebook so you can take notes very quickly. And particularly if your boat is moving, these need to be taken one after the other, bang, bang, bang. But a word of warning, the compass doesn't tell the truth. It doesn't point to north. There are two errors. One is caused by the Earth, which is variation, and that's a known quantity for any given area or any given year. But the other is a deviation. Now, with a fixed compass on a boat, you've got a deviation card, but with a handheld compass, you've got to make sure that you're in a magnetically clean area of the boat. So stay away from electronics, stay away from the outboard engine hanging over the back rail, stay away from the engine. But also make sure you don't have any handheld VHFs hanging off you. And as is usual, I tend to have a VHF on my belt somewhere. So I'm just going to put that down out of magnetic reach of my hand bearing compass, so the handheld radio is not interfering with it. Another thing is lately there are reading glasses which you can get that split on the bridge and you can hang them around your neck, but there's a little magnetic catch in the middle of the reading glasses, and if you use reading glasses to use your hand bearing compass, make sure there's no magnetic interference from the reading glasses themselves. That's quite a common mistake. And of course the mobile phones, we're always carrying them. Put it down, get it away from you, at least 1 meter away from the compass when we're using it. So that's it, I'm ready to take my bearing now. So I'm going to start with Rose Street and swiftly move to Bright Street, and thereafter that we will move to the Black Man. So I line it up against my nose like that, and not out here, it's hard to see. And when you're looking at the compass, you line it up and look through that window there, and you should see a red line and another red line in your lower peripheral vision. So in your lower peripheral vision you're using the red line there, but you're looking through there and you line up the two red lines. This is Rose Street. Two 251. 211 onto Bright Street. 128 onto the Black Man there just beside the ship. So that's my three bearings.
So I'm back at the chart table now using chart 1772, which is the chart for Wexford Harbour. And it's a chart covering a small area, it's in a large scale. So we've the two churches, the northern one of the two, Rose Street at 251 degrees, Bright Street at 211 degrees, and Black Man at 128 degrees. So there's a decent cut between those. Generally, you should be looking for about 120 degrees across the three of those, but that's not always possible. So I first dial in. I can't just use 251 straight. I'm just dialing it in here. I can't use that straight because the compass is not telling the true position because of the issue of variation caused by the Earth. So the error is 2 degrees west. So I'm just going to put the 251 instead of the 0. I'm just going to move the 251 to there, which gives me a true reading of 249. So again, I watch where my little arrows are. There's my little arrows. And my blue arrow points towards the church. So I've identified the church is here. And then I move this around until the crisscross in the middle lines up with the verticals and the horizontals underneath. So we'll find something there. So there we go. Okay, so that's pretty good. That's lined up on the spire, and I just draw my first line in there, just one single line, and that's my 251 corrected to true, which is 249. The next one is 211. So the same thing here. I dial in 211, but again, I don't dial it onto the 0. I dial it in onto the 2 degrees west. So the error is west, error west. So I just bring the 211 point around to reading 2 degrees west. So that's it there. Don't touch the dial now. The little blue arrows there are pointing north, and I manipulate it around so it's on the southern of the two churches. And again, I use my crisscross to find, there we go. So that's pretty good there. Just double check that, not quite, just fiddle around with it. And I draw my line there. So if we just trusted 2 lines, my position will be there, but you never trust 2 lines. So I'm taking the third one from Black Man. So Black Man is 128. Now I said in the video incorrectly, it was 129. It's 128. So again, I dial in 128 there. And this time, again, because the error is 2 degrees west, I move this 2. So I put the 128 on the 2 there. Okay, so that's looking good. Move the whole thing around, don't touch the dial now, making sure this little blue arrows are pointing north, and just lay it down. So I'm using the crisscross again on the grade until I've got Black Man. Just move it around. That's looking pretty good. And I draw my line. Now, as it happens, my little triangle is very small there, which means I got a good reading. So I'm somewhere there. I was actually standing on the corner of the pier here, so I'm happy that that is a good position. And I would note the time down and what time I took the position. I can also read off the latitude and longitude, so I'll start off with latitude. So ignore this here, and I'm just making sure the thing is level. So that's my latitude and my longitude. Check that there. So this one here then is 52 degrees 20, and up there's 21, so it's 20.1, 0.2, 0.3, 0.4, 20.4. No, and my longitude, remember, it goes this way from Greenwich, so that's 00627, that's 28, so it's 27.1, 2, 3. So it's 006 degrees 27.3 west. Write that down here. My position is 52 degrees 20.4 minutes north, and 006 degrees 27 minutes 3 west.
And the electronic twin of the 3-bearing fix would be radar range. So with the 3-bearing fix, we're taking our position on 3 bearings. With the radar range is we take a range from 3 objects, because the radar isn't totally reliable in giving us a bearing to an object, but it is reliable around a distance of an object with a good radar reflection, such as a lighthouse or a raycon or a quay wall or something, a quite distinctive cliff on the coastline. And by taking the range to 3 objects, it's the same concept. And then we're into hybrid means. So we could, for example, take a transit and then take a bearing on another object. Or we could take a transit and read the depth sounder and correct that for tide. And you could, it's a combination of transit and depth contour. Following on from that, you could take a radar range on an object that you can see and then take a visual bearing, a compass bearing on that, and that gives you a pretty good position. you could have just the bearing, a single bearing on a sounding, obviously not as accurate as the transit and sounding. And finally, if you're on the Yachtmaster course, you can also look at dipping lights. So each light is, such as a lighthouse, bigger lights, are a determined height above the horizon. And you know the height of your boat above the horizon. Typically on the deck of a yacht, you're 2 meters above the horizon. And you can do the calculations and you can work out exactly when that light will appear above the horizon. This is very useful at night, and it works really well going up the Irish Sea. And at times you can see the dipping lights from both sides of the Irish Sea. So there you have it. Now that's plotting a fix. There's lots of different methods, there's no one size fits all, and you'll be using different techniques depending on the circumstances. But one of the absolute joys of coastal navigation by day or by night is taking a fix, determining where you are and confirming that by other means, whether it's by GPS or by visual or by radar, and that there is quite a sense of satisfaction of knowing that you've got it right, and that leads to safe and confident navigation. So remember, the art of navigation is where am I now, where do I want to go, how am I going to get there, and how do I check that I'm on course.